So if you go down here to midterm 1, you can see all the stuff. But specifically midterm 1, you look at it, there's a lot of things to read. I do encourage you to read all of this just so that you know what's going on before you start the test. So do read this. It's not a lot of reading, but it does have pertinent information. I do recommend, if you can, printing out the exam, but if you can't, that's really fine. You can answer your questions on just regular paper. I would probably prefer online paper, but flying, perfectly fine. I would probably prefer not graph paper because it makes it harder when you scan things, but again, do try to write legibly. Most of you are doing a very good job at that. A few of you, some of your stuff is kind of hard to read, so try your best. If I have a question, I will definitely ask you about it. So, yeah. All right, let's get started on this practice test. I mean, actually, this actual test I gave in fall of 2018. And let's turn this brightness up here. What's that? Yeah, I can totally like it. Do you want it off?
No, yeah.
Sorry, I'm not quite hearing what you're saying.
Like you turn the light off and
Oh, sure.
it will be a lot clearer.
Yeah, you think it's good to light the overhead lights, you mean?
Yeah.
Good question. I hadn't thought about that. Is that better? A little.
I think you just put the
I don't mind
all the way up there.
I don't mind being over here in the somewhat dark. It's kind of weird to be in a dark classroom, but if this is better, I'm happy to make it better. No one's gonna fall asleep, right? I mean, okay. So let's get going. Log base 5 of 1/25. You don't have to show any work. So if I wasn't showing you work, I'd be like, oh, I know the power is -2. But if you need to do some work on your own, be like, oh, log base 5 of 1/25 equals x. 5 to the x is 1/25. That's 1/5 squared. That's 5 to the -2. So x has to be -2. You don't need to show this work, but you might need to do this work to solve it. Yeah.
So we don't have to show.
Nothing. This is all you have to write.
Not on this page.
So this first page, no work needs to be shown. You can just write the answers. You should not use a calculator. The y-intercept of this f of x equal to 3x squared plus 6x minus 8. So the y-intercept is going to be -8. Plug in 0 for x. Get 0 plus 0 minus 8 for y. I could zoom in a little bit here. How about that? That would be smart. I always forget about the zooming in, right? I don't see, right? I can't really, like, I can see up there, but I'm not looking there. So, yeah, that's better. The center of the circle, x plus 2 squared plus y minus 7 squared equal to 11. So the center is going to be the x coordinates -2, the y coordinates +7. And the radius is going to be the square root of 11. Vertex of the parabola, y equal to 3 times x plus 2 squared plus 8. So this is written in the vertex form. It's meant so the vertex is really easy to read. So the x coordinate is going to be the opposite of that value. So x is going to be -2. Because you're trying to get that part there in the parentheses to equal 0. And -2 plus 2 is 0. And then if x is -2, what are we left with for y? Well, 0 plus 8 has got to be 8. Don't need to show any work here. Question? What's that? I believe so. Now you've got me worried I'm not. Let me double check. I'm like, oh no, am I not? No, I'm definitely recording. Yeah. There is also a video of me going over maybe the same practice test, maybe a different practice test already posted from last time I taught this class. So yeah.
Sorry, could you remind me why this was negative again?
So this is a parabola, right? Which way does it open? Up or down? Definitely opens up. So it does something like this. And we're trying to find the vertex, which is the lowest point. The lowest point is going to be when you have the smallest y value. Well, the smallest that this whole expression can be here is going to be when this part here, well, the smallest something squared can be is 0. That's the smallest that part can be. And for this part to equal 0, x has to be -2. So that's what you're always looking to achieve when you're finding the vertex of a parabola written in the vertex form. You're like, oh, this part needs to be either as small or as big as possible. If there's a negative sign out in front, right? Making it 0, make it as big as possible. But you're always trying to make this part 0. So the x always has to end up being the opposite sign of whatever is over here. Yeah, that's it. Yeah.
I'm a little late. Like for number 2, would you write it as 0, -8, or is it like?
You're making a good point. I would totally accept -8, but you're right. 0, -8 is the more precise way of writing that for sure. But if you wrote just -8, I would totally take it. All right. The exact value of the natural log of e is 1. What if instead, though, what if I ask the exact value of, say, log base 2 of the square root of 2? What would that be? It'd be 1/2. We have log base 2 of 2 to what power? To the 1/2 power. And 2 raised to the 1/2 power equals 2 raised to the 1/2 power. Or if you prefer, that comes down. And 1/2 times log base 2 of 2 is 1/2 times 1. Got questions, ask them. All right, number 6. In the equation, a equals p times 1 plus r over n to the nt, which is the compound interest formula. Interest compounded monthly would make n equal to how much? Exactly, right? Because we're compounding it 12 times per year, right? Once every month. So n is just the number of times per year you would compound something. So if we were compounding it daily, what would n be? 365, right? Because you would do it 365 times per year, once every day. Monthly is once every month. Weekly is once every week.
So if they said yearly.
1, right? If you're compounding it yearly, your n is going to be 1. Or they might say compounding it annually. Same thing. We can rewrite 5 to the x equal to 23 as log base what? Of what? Yeah, equals the exponent x. Okay. True or false? The square root of 6 squared plus 8 squared equals 6 plus 8. You could actually calculate it. 6 squared is 36. 8 squared is 64. And the square root of 100 is not equal to 14. You could also figure out this, right? Square root of 100 specifically is 10. But in general, right, you can't take a square root of 2 things squared and just square root each of them. It doesn't work. Okay, let me make sure. Look out for questions too. All right. Moving along. For the remainder of the problems on this exam, you must show your work in order to receive credit. It's a good thing to remember. So please do show your work. I want to see it. The more work you show, even if you get a wrong answer, the more likely I am able to award you partial credit. And I'm definitely in the business of trying to award as much partial credit as I can. So show your work. All right, so find a numerical answer for x. We're going to rewrite this logarithmic equation as 3 to the x equal to the square root of 27. And I really want to write both sides as powers of the same base. So here's the thing. You could totally solve this. I mean, technically, this is already solved, I guess, but we want a simplified answer. We want to rewrite this in a way so that, I guess I'm thinking about this, like this might not be the best way to do this problem. This is the way my brain sees it at first, but I'm going to show you another way too, because you probably are thinking of this as in a different, I'm like, oh, there's a totally better way to do this, but I've started down this path, so let me just show you. This would be 27 to the what power? And then 27 is, bless you, 3 to the third, to the 1/2. And then when you have a power to a power, we multiply the power. So 3 to the x equals 3 to the 3/2. So x has to equal 3/2. That's probably not the best way to do that problem. Another better way might be just to be like, well, hey, look, log base 3 of the square root of 27 is log base 3 of 27 to the 1/2. And the 1/2 can come down in front. 1/2 times log base 3 of 27. What's log base 3 of 27? 3. So you get 1/2 times 3, which is equal to 3/2. Either way is totally acceptable. I think the reason I saw it this green way first is because it's written as equal to something. So I wanted to rewrite it, but I didn't need to. So either way is fine. Find the equation of the line through the points -1, +1, -5, and 4, 7. Find the equation of the line. We need first the slope. And we're going to do the difference in the y's over the difference in the x's. I'm going to do this one minus that one. So 7 minus -5 over 4 minus 1. It's going to be +12 over 3, which is 4. You could also do the subtraction the other way. You could also do it as -5 minus 7 over 1 minus 4. And that would be -12 over -3. There's my slope. And you can kind of do this next part either way, but I'm going to show it this way. We're going to do y equals mx plus b, and then just pick one of the 2 points to plug in to find b. Either one. I'm going to pick the first one. So y is -5 and x is 1. So then subtracting 4 from both sides, -5 minus 4 is -9 equal to b. And then once we get b, we do need to rewrite the equation of the line. So we're going to say, oh, my equation is now going to be y equal to 4x plus -9 or minus 9. Right? Go on to the next one. Use properties of logs to simplify this expression to a numerical answer. So we want to smoosh this together as one logarithm. And it's going to simplify to a relatively nice number. You know, those things small. So I've got log base 3 of 2 plus 2 log base 3 of 6 minus 1/2 log base 3 of 64. And before you can compress the logarithms into one logarithm, we have to get rid of those coefficients, meaning they have to come up as powers. So I'm going to rewrite this as log base 3 of 2 plus log base 3 of 6 squared. And you can either, I'm going to do this as minus log base 3 of 64 to the 1/2 power. And these are all things we can compute. We got log base 3 of 2 plus what's 6 squared? What's 64 to the 1/2 power? Right. And then we can combine these together and write this as, and you can do your combinations and you can do it in 2 steps or one. In one step, it would be log base 3 of 2 times 36 all divided by 8. Or you could take 2 steps and say, I'm going to put these together first and say it's log base 3 of 2 times 36, still minus log base 3 of 8. I don't really want to do 2 times 36. I don't need to. I'm going to combine this and get log base 3 of 2 times 36 over 8. And then I can cancel. Right? I can cancel a 2 and a 2. And then 36 divided by 4 is 9. We got log base 3 of 9, and that's equal to 2.
Why did you put the 2 in the exponent?
So the reason I put this 2 in the exponent and this 1/2 in the exponent was so that I could then add the logarithms, or I could compress the logarithms together. So when you're saying like log of something plus log of something else equals log of the things multiplied together, You can't use that rule if you've got coefficients out here that are different. So I wanted to get no, or really coefficients that were all 1 before, so that I could then take this and say, oh yeah, now that I've got log without a coefficient or a coefficient of 1 and another log here, I can put these together as log base 3 of 2 times 36. But I couldn't do that when it was like this. This here, you have to kind of do that step of bringing the two up before you can compress them into one logarithm. A good question. Other questions? Solve for x. I've got e to the x plus 2 equals 5 to the x. What should I do to both sides? Take the logarithm. Specifically here, you should default to the natural log. Although any choice is really fine, the natural log is the best choice here. I'm going to take the natural log of e to the x plus 2 equal to the natural log of 5 to the x. And then the next step we should make is to bring down the powers. So that's going to be x plus 2 times the natural log of e equal to x times the natural log of 5. If your base was 10 instead of e, I would use log base 10. But if neither 10 nor e were your bases, like if it was like 5 to the x equal to 7 to the x plus 2, I would just use natural log. But any choice is fine. Now we're gonna, well, we would normally distribute this, but natural log of e is just 1. So we don't really have to distribute that. So I'm just gonna say, oh yeah, that's 1. So we're gonna get x plus 2 equal to x times natural log of 5. And then we're gonna try to solve for x. I'm gonna subtract x from both sides. So you get 2 equal to x times natural log of 5 minus x. And here's a step where I feel like a few people do get kind of caught up sometimes. Once we've got all the terms that have an x on the same side, we have to factor out an x. Or divide out an x is another way you can say that. So factoring out an x, I'm going to have natural log of 5 minus 1 after I divide each term by x. And then the last step is to divide by this coefficient of x. So that x will equal to divided by the natural log of 5 minus 1. There are other correct ways of expressing this. This is the way I think is the easiest. Yeah. Well, sorry, can you say that one more time?
When you factor up the x, and that's like almost last step, negative x, negative 1.
Right.
And
So
then the positive x just stays there.
well, so what's happening here is what we have in this step here on the right side is x times natural log of 5 minus x times 1, if you like. And then I'm dividing out the x so that I have now x times the quantity natural log of 5 minus 1. So if I redistributed this, I would get x times natural log of 5 minus x times 1. It would be the same as the term as the thing before.
Okay.
Question.
So I moved the 2 over to the other side and then -2, so I have all the x's on the same side.
Sure.
And that the final answer is like negative.
So your final answer then should have been -2 over 1 minus natural log of 5.
Yes. So that is
Perfectly fine.
okay.
Yeah. Yeah. If your answer looks the same as this, but it's all everything is the opposite sign, also totally fine. And again, I said, right, your answer might look a little bit different and still be correct. So I will definitely make right. I'm not focusing on one specific version of the answer. As long as your answer is right, it's okay, but looks a little different. That's really it. Okay. So good questions. One is okay. All right. On to question 13. Some graphing. Sketch graphs of each of the following equations listed below on the XY plane below. I seem to say below one more time. Be sure to label the points of intersection. You should also label the other usual things that are being asked to find: the x-intercept, the y-intercept, the vertex, x-intercept, y-intercept. Okay. Yeah.
In a case like this, you want us to show our work how we got the x and y intercept?
Yeah, I do. Yeah. So And so I feel like I've written these in the not usual order I would find them in. If I was graphing a parabola, I would definitely find the vertex first. So the vertex, the x coordinate for the vertex is going to be negative b over 2a, which is negative 2 over 2 times 1, which is negative 1. And the y coordinate of my vertex, I'm just going to plug that negative 1 back in for x. Negative 1 quantity squared plus 2 times negative 1 minus 3. That's going to be 1 minus 2 minus 3, which is negative 4. My vertex is negative 1, negative 4. And I might start just even plotting things as I go here. So negative 1, negative 4, great. There's my vertex. Oh, sorry. There's my vertex. I might have to zoom out. We'll see. The y-intercept is what I would usually find next. And that's going to be, well, if I set y equal to, x equal to 0, we're going to get y equal to negative 3. Plot it on the plot here. Right there. And then my x-intercepts, we're going to set y equal to 0. So we're setting x squared plus 2x minus 3 equal to 0. And unless someone has decided to be incredibly cruel, I mean, not incredibly cruel, but not very nice, this is going to factor. This factors is x plus 3 times x minus 1. So my x-intercepts are going to be negative 3 and positive 1. So graphically, positive 1 right there. Negative 3, 1, 2, 3 right there. So there's my parabola, or at least some points on the parabola. And I'm not going to graph it just yet because even though I could do a pretty good job of it, I want to pay special attention to what the points of intersection are going to be. So I'm going to hold off on graphing. I'm also going to graph, but I will graph the straight line because straight lines are pretty easy to graph correctly, I would say. So for this straight line, y equal to negative x plus 1, my y-intercept is going to be 1. I do think you can get away without showing any work for the y-intercept. Like I believe that all of you can plug in 0 for x and easily see what the y value is. So if x is 0, y is 1. X-intercept, I mean, this one's not too bad either, but with the x-intercept, if we set y equal to 0, we get negative x plus 1 equal to 0, we get 1 equal to x. So 1, 0. Now we happen to get lucky, and one of our intercepts actually is one of the points of intersection. Yep. So there's my straight line with a y-intercept of 1 and an x-intercept of 1. And we do know something, right? We know that these are definitely going to intersect when x is equal to 1, which is nice. We might not get that on the actual test, but I can see that here. So we know that when we're trying to find the points of intersection, one of our solutions should be that x equals 1. Great. So to find the points of intersection, oh my black pens like got lost in the mail or something. I'm still waiting on them. I mean, I guess I could go just buy some, but the school is supposed to provide me with the materials I need to do my job. Okay, the points of intersection, we're going to set x squared plus 2x minus 3 equal to negative x plus 1. And then we're going to bring everything to one side. So I'm going to add x to both sides. So 2x plus x is 3x. And I'm going to subtract 1 from both sides. And then I'm going to factor. That's going to factor is x plus 4. Yeah, this pen is just dead. Write it in a different color. Times x minus 1. So the x coordinates of my points of intersection are x equal to negative 4 and x equal to positive 1. But really, I should also find the y coordinates because we're being asked for them. So if x equals negative 4, y is going to equal. So here's the thing, right? We're not plugging back into this equation. We're trying to find the point either on the line or on the parabola. Which of those two functions is easier to plug back into? The line or the parabola? Definitely the line, every time. If I plug in negative 4 for x, what am I going to get for y? Oh, you're so close. But so if x was positive 4, I would get negative 3. But I'm plugging in negative 4, so I'm going to get what? Positive 5. So one of my intersection points is negative 4, 5. And the other one we already knew was going to be 1, 0. But if we plug back in x equal to 1, oh yeah, negative 1 plus 1 is 0. So those are my two intersection points. 1, 0 right there, and negative 4, 5 right there. Negative 4, 5, 1, 0. So then I would graph my parabola, doing the best job I can, but knowing that it doesn't have to be perfect. Thanks. I mean, I have a lot of points to plot, so right, the more points you've got, the easier it is to make it look really good. Yeah.
Can we use the parabola or the line to form an intersection?
Yes, exactly. So again, but you're always setting them equal to each other. Setting them equal to each other is what allows you to find the x coordinates. And then you totally could, instead of plugging back in negative 4 to the line, you could plug in negative 4 to the parabola. And if you do, you should get the same value. Let's check just to be sure. We plug in negative 4, we're going to get negative 4 squared plus 2 times negative 4 minus 3, and that's going to be 16 minus 8 minus 3, which is 8 minus 3, which is 5. So yeah, it should be the same either way. But I would encourage you to take the easier route. Okay. Yeah, label the points of intersection. I think we labeled them. We're good to go. All right. Get the next question. Find the center and radius of a circle with the following equation. 4x squared plus 4y squared minus 24y, 24x plus 8x totally equals 0. So before we get started here, I would really like to divide both sides by what? 4. 4 is problematic. And luckily, everything's a multiple of 4. So we divide by 4, we get x squared plus y squared minus 6x plus 2y plus 3 equal to 0 divided by 4 is 0. I mean, it was really itches. It's like terrible. Sorry. Okay. And then we're going to do the completing the square thing. X squared minus 6x, and we're going to leave us some space. We're going to have y squared plus 2y, and we're going to leave ourselves some space. And we're going to bring the 3 over to the other side. So it's a negative 3. And then we're going to add on the thing, whatever we add on here, we got to add on over there too. So for x squared minus 6x, what do I need to complete the square? I need negative 6 over 2 squared, which is 9. You're taking the coefficient of x, dividing it by 2, and squaring it. Add 9 there, we got to add 9 there. And then for this one, I'm taking that 2, dividing it by 2, and squaring it. And 2 over 2 squared is 1. All right. So after we've completed the square on both sides, then we want to factor this side. And this side's going to factor as, so here's what I really want you to see. It factors as x minus 6 halves squared. Whatever that number is before you square it, that's how this piece actually factors. Now I would write x minus 3 squared, but that's where it's really coming from. And the same deal here. This whole thing here is going to be y plus 2 over 2 squared. Negative 3 plus 9 plus 1 is 7. So I might rewrite this as x minus, I would definitely write this as x minus 3 squared plus y plus 1 squared equal to 7. Now, we can't stop there. We didn't answer the question. Because the question is, find the center and radius. So after we've written it in the way where we can see the center and radius, then we need to actually write down what they are. So my center is what coordinates? 3 and negative 1. The radius is exactly. It's not very nice, but it is the square root of 7. Question?
Would you not multiply 4 by 4?
No, I wouldn't. So so you're right. We have changed the equation slightly. We have changed it in a non-significant way. So I will point out graphing that, if you were asked to graph this, the graph of this and the graph of this are entirely the same. It's different when you, so it's different, right? Because usually, and this is not a function, it's a circle. Usually when you have like y equal to something with x squared, like if you had a parabola and you multiplied one side by 4, you'd also have to multiply the other side by 4. We did that here. It's just the other side was 0, so it didn't have an effect. But you're not wrong to think about that. It's just, it's not necessary here. Right, right. And for a parabola, you definitely do need to do that if you're completing the square to find the vertex. But for a circle, it's not necessary.
Oh, so like when you divide like -6 divided by 2, like what is the 2?
The 2 comes from, that's the process that we've worked, right? It's not, I mean, it's really because there's a way that I can show that makes that work. I don't want to take the time to do that right now, but it's really because we know that doing that will allow us to complete the square.
Oh, so it's always.
Right, it's always divided, it's always the middle term, right? If you've got, or it's like the coefficient of the things to the first power, it's always that number, -6 for the x's, +2 for the y's. It's always that number divided by 2, always 2 squared. That's what we're adding on to each piece. Okay, other questions? Good questions. All right, a 20-gram sample of a radioactive isotope decays to 15 grams in 8 days. How long will it take until there are 2 grams left? And when you see a question like that, like this, I would highly encourage you to make a little table. I think the table is a super effective tool to use. In my left column, I have time. In my right column, I have y, the amount of stuff. And well, yeah, you can either do it. I don't see it. Let me just write down stuff. So let's see, 20-gram sample of radioactive isotope decays 15 grams. So I know that the time equals the beginning. I have 20 grams. And then 8 days later, I have 15 grams. So typically in this sort of situation, you're going to have 2 data points. Usually the beginning, usually some other time, and then they're going to ask you for something else. In this particular problem, they're asking me what? Right, the time when it's 2. So I'm looking for the time when the amount is 2. Great. There are 2 equally good ways you can do this problem. The long way or the short way. Here's the short way. We know that our equation is going to be y equal to, what's the initial amount? Okay, here's a harder question. What's the multiplying factor? So the multiplying factor is always how much you multiply to get from the amount from the beginning you know to the next place you know. So from here to here, what do you multiply by? And I'm sure you guys are all saying lovely answers that I can't quite understand. I think someone said 3/4. An easier answer would just be say 15/20. Right? It's definitely true that 20 times 15/20 equals 15. So if you're doing this short way, you're always looking for the multiplying factor, which is 15/20, which reduces to 3/4. All right, how long did it take to get there? 8 days, so that's going to be to the t/8 power. So if you're doing this short way, it's always the initial amount times the multiplying factor to the t divided by the number of days it took to multiply by that. By the multiplying factor. That's a lot of writing, I know. You are welcome to do it this way. Or you can definitely do it the other way, where I might need more paper here. We'll see. Yeah, let's just get another piece of paper. So the other way you would say, well, I'm going to start off with the, sorry. thumbs, I'm all thumbs. Okay. Or you could say, we're going to start off with the model y equals c e to the kt. But again, we know the initial value is 20. And then we're going to use this other data point to plug in and find k. So we're going to plug in t equals 8 and y equals 15. So we're going to get 15 equal to 20 e to the k times 8. Divide both sides by 20. E to the 8k. And then take the natural log of both sides. I would reduce 15/20 to 3/4. It's not absolutely required, but it's pretty typical. The natural log of 3/4 equals the natural log of e to the 8k. Everybody should be able to tell me what's the natural log of e to the 8k. Right. Natural log of e to the stuff is just the stuff. Finally, k equals the natural log of 3/4 divided by 8. So either our model is this, or our model, you can't see me writing there, is y equal to c e to the k t. Either one of those ways is perfectly fine. You should do whatever you're more comfortable with. Okay. So then we want to answer the question, right? So you got to find, so whenever you're asked an exponential growth or decay question, the first order of business is to find the model for the growth or decay. Here's the model. We know that whatever time t, y is going to equal, or the amount's going to equal 20 times e to the natural log of 3/4 over 8 times t, or y is going to equal 20 times 15/20 to the t over 8. And then to answer the question, we're going to do what? Well, they asked us, what time is it when we have 2 grams left? So we're going to set y equal to 2 and solve for time. I do think it's easier to solve for this, solve for time specifically in this particular version. But again, I'll show both. So if we set y equal to 2, we're going to have 2 equal to 20 times 15 over 20, which I'm going to reduce to 3/4 in the next step to the t over 8. What do I do next? So whenever you're trying to solve for an exponent here, you need to get rid of this coefficient. So we're going to divide by 20. So 2 over 20 equals 3/4 to the t over 8. Then we're going to take the natural log of both sides. 2 over 20 reduces to 1/10. So the natural log of 1/10 equal to the natural log of 3/4 to the t over 8. The t over 8 comes down. So we have the natural log of 1/10, or you can write 0.1 if you prefer decimals, equals t over 8 times the natural log of 3/4. Finally, I'm going to multiply both sides by 8. So 8 times the natural log of 1/10 equals t times the natural log of 3/4. And then I'm going to divide both sides by the natural log of 3/4. So the 8 times the natural log of 1/10 divided by the natural log of 3/4 equals t. It's never going to be a pretty answer. I do think in the test I've written that I've also asked you to give me a decimal approximation to 1 decimal place. So you will actually need to use a calculator for that. Just so you can see the other way as well. So if I was doing it this other way, I would set this equal to 2. So 2 equals 20 e to the natural log of 3/4 over 8 times t. Divide both sides by 20. So 2 over 20 is 1/10. Equals e to the natural log of 3/4 over 8 times t. And then take the natural log of both sides. It gets a little bit gross. The natural log of 1/10 equals the natural log of e to the natural log of 3/4 over 8 times t. Blah. But we know again, the natural log of e to some stuff is just that stuff. So we know that we really have the natural log of 1/10 equals just this exponent here. The natural log of 3/4 over 8 times t. And then we're back in the same place we were for the other one. We're going to multiply both sides by 8. We're going to divide both sides by natural log of 3/4. So either way, you do get the same answer for t, which you should, because it's the same problem. Any questions about that? Whenever I say any questions, I always think about that PSA from like the 80s or 90s. This is your brain. This is your brain on drugs. And you're like, smash the egg with the frying pan or whatever. Got any questions? That's what I always feel like I'm saying when they say got any. I don't really think that, but like, got any questions? Okay. All right. So find the point on the line y equals 2x plus 1 closest to the point 5, 1. Hint, you have to minimize something. You have to minimize the distance between the two things. You don't have to draw a picture, but I like to draw a picture. 5, 1 is maybe over here. And we're trying to minimize the distance between some point on this line that we don't know yet, and it's probably not going to be very nice. I'm going to say it's about right there. I'm going to call it x, y, because I don't know what it is. And we want to minimize that distance, or really the square of that distance, because that's going to be easier. So my distance between those 2 points is the square root of x minus 5 squared plus y minus 1 squared. It doesn't suck. But really, we're going to minimize the distance squared. Now, as is typical, we can't minimize a function of 2 different variables. We need to use the constraint. And the constraint here, right, the thing that needs to be true that we are being held to is that the point we're looking at needs to actually be on this line. So our constraint is that y has to equal 2x plus 1. So we're going to plug that in for y. I mean, I suppose you could solve for x, but you should, right, y is already solved for, you should just use that. So our constraint is y equals 2x plus 1, and we're going to substitute that in for y right there. So now we're going to minimize the distance squared, which is x minus 5 squared plus 2x plus 1 minus 1 squared. Now we're going to multiply it out. So x minus 5 quantity squared is x squared minus 10x plus 25. And this here, we don't want to do like a FOIL thing. We want to be like, oh, 2x plus 1 minus 1 is just 2x.
I'm just gonna ask, like, did the parentheses like not let you?
No, they definitely don't prevent you, right? Really, I mean, we just have 2x plus 1 minus 1, the ones cancel. And then 2x quantity squared is going to be 2 squared times x squared. Or 2x times 2x, which is 4 times x squared. And then we want to combine the like terms and get the distance squared is 5x squared minus 10x plus 25. And now we're going to find the vertex of this quadratic. Specifically the x coordinate. We actually don't care about the y coordinate. The x coordinate is the x point on the line here. The y coordinate of this vertex would be the minimum distance squared, which although is useful information, it's not what they're asking for, right? They're only asking for the point. So we're going to find the vertex, the x coordinate anyway. It's going to be negative 10 over 2 times 5, which is going to be positive 1. And then the y coordinate, we're not plugging back in to find the y coordinate of the vertex. We're plugging back into our constraint and saying, oh, well, if x equals 1, y is going to equal 2 times 1 plus 1, which is 3. So the point on the line that is closest to the point 5, 1 is the point 1, 3. So it is 10:50, which means 2 classes over. There is one question we didn't get to. I'm happy to go over it if you want to stick around because you have office hours next. If you got to go, I understand you got to go. So if you need to go, go. I'll give you a minute. I'll work over this problem. For those of you on Zoom as well, you're welcome to stay or go. And then we'll have office hours. So I'll work through this problem real quick. It'll also get posted on, like, I'll post the video shortly after class. Also, the solutions are already on Canvas. So I'll give you people who need to leave a moment to leave, and then we'll do this problem. You're welcome. Okay. So a zoo is planning on building 2 adjacent rectangular enclosures for the lion and giraffe exhibit. These lions and giraffes again. All right. The material for the outside perimeter of both rectangles costs $5 per foot. Oh, no problem at all. Yeah, of course. Yeah. You do the lights on. It is a little dark. All right. Yeah. No problem. It's still pretty. I mean, I do agree. It's easier to read it when the lights are low, but I also like having the lights on. So 2 enclosures, one for the lions, one for the giraffes. The outside perimeter of both rectangles costs $5 per foot. The dividing fence costs $10 per foot. So I want to label the sides of this, and there's actually 2 equally good ways of labeling it. Question?
Is there going to be an extra kind of question?
Yes, for sure. So I would label these sides all the same, X, X, X. And then I personally would choose to label this entire length as Y and this entire length as Y. Although it's also perfectly legitimate to label each of these lengths as Y, like a Y here and a Y here and a Y here and a Y here. That would also be totally fine. Yeah, it'd be fine. So I'm going to label it this way. And let's see what we've got. So we're trying to maximize, well, actually, what are we trying to do here? The zoo has budgeted $2,000 for the project. What should be the dimensions of the 2 exhibits combined in order to maximize the total area of both exhibits? So we want to maximize area, which is X times Y. I will just point out, if you did it this way instead, where you called this Y, and this Y, and this Y, and this Y, you would be trying to maximize area, which is X times 2Y. It still ends up being the same, but it is a slightly different thing. Okay. As usual, I'm trying to maximize something that has 2 variables in it. We need a constraint. And here the constraint is our budget. Right? We have budgetary constraints. So our budget is that all the amounts have to add up to 2 grand. So doing it the way I'm doing it, I know that the 4 outer sides cost $5 per foot. So this top side is going to cost $5 times Y. This bottom side is going to cost $5 times Y. This left side is going to cost $5 times X. This right side is going to cost $5 times X. And then this side in the middle, which needs to be stronger, is going to cost $10 times X. And that's going to equal 2,000. Just to point out, if you were doing it the other way, you would have more Y's, right? You would have 5Y plus 5Y plus 5Y plus 5Y. And then you would have 5X plus 5X plus 10X equal to 2,000. We should simplify these. This one definitely simplifies to 10Y plus 20X equals 2,000. This one simplifies to 20Y plus 20X equals 2,000. Okay. So now we're going to plug that back into our equation. The one in green, area equals X times Y. Oh, no, I'm not going to plug that. I need to do a thing first, right? I need to solve for one of these variables. I'm typically going to solve for Y. So solving this one for Y, I'm going to get 10Y equal to 2,000 minus 20X. Divided by 10, Y is going to be 200 minus 2X. This one here, if I solve for Y, you can just divide everything by 20 really easily. Y plus X wrong pen, equals 100. Y equals 100 minus X. So for this one in green, you're getting the area is X times 200 minus 2X. This one in black, you're getting the area is X times 2 times Y. Oh, look, we got the same equation. Because it's the same equation, right? The X value should be the same either way, because the X is called the same thing. So it does really work no matter which way you label it. For both of these, I should multiply them out. I'm just going to do one of them because they're actually literally the same. This is 200x minus 2x squared. Do be careful. If you write it this way, what's my a value? Like I'm thinking of the parabola as ax squared plus bx plus c. My a value is what? Right, it's -2. It's the coefficient of x. So if it's confusing to you when it's written out of order, write it in order. Write it as -2x squared plus 200x. Just to make sure we don't go haywire. And then our a value is -2, our b value is positive 200, and our x coordinate of the vertex is -b over 2 times -2. That's going to be 200 over 4, which is 50. We do not need to find the y coordinate of the vertex or the second coordinate of the vertex. The second coordinate of the vertex would just be the area, which is nice, but not required. What we need is y. So using this constraint, our y value would be 200 minus 2 times 50, which is 200 minus 100, which is 100. Now I'll point out that if we were doing this one instead, we still would have gotten the same x value because it's literally the same equation. But if we plug back in for our constraint here, you'd be getting y equal to 50. That's okay because in that situation, where y equal to 50 really means this side is still 100 long because it's 50 here and it's 50 here. So either way, you're getting the dimensions being 100 wide by 50 high. So 100 feet by 50 feet. Oh, sorry, computer.